So far you guys have been working very hard and to understand the mathematical framework of physics and I would say science. So what really we need to understand physics, not only understand, but to interpret in a very correct mathematical order. And that needs some underpinning, or that needs some idea about basic math. So we all have gone through those basic mathematical tools which you will be employing in solving the future chapters. Now that journey is not over. Rather, what I would say that is that has just begun. You all need to keep on revising, keep on solving questions. Don't leave even a single day without solving few question of calculus or revising the formula of trigonometry. So all the trigonometric formula just keep put on a paper and put in front of your desk so that every day you can see it, you can recall it, because it will take some time before it becomes part of your permanent memory. Okay. So after learning the mathematical tools, which is the prerequisite to understand the physics, and let me make it very clear that the 11th physics is the real physics. The 12th is just some cosmetic changes. So if you really want to command physics at a JEE advanced level or Olympiad level, you have to put some extra effort in class 11. And then trust me, your class 12 will be just like a breeze. Okay. So we are entering into a world which we call mechanics. And the mechanics will have multiple branches. Let me show you each branch of mechanics. So the first branch of mechanics we call Newtonian mechanics. And in the Newtonian mechanics, we ignore the variation of mass with velocity. And in a way, we don't consider the relativistic effect, which you will see in the chapter of the Einsteinian, you can say Einstein mechanics, or we say the relativistic mechanics. So Newtonian mechanics is one part. The other part we can call is the relativistic mechanics, and it is also called the Einstein. You can call Einsteinian mechanics. And here things will change. So here the time which we use thing is a quantity which do not change from one frame of reference to another frame of reference. So whether you have a clock at your home or whether you have a clock at your wrist and you're running, or whether the clock is fitted with a local train or supersonic jet, the clock will give you the same time no matter which frame you choose, whether it's at rest or in motion. But to your surprise, that thing is not true in the world of Einstein. So the relativistic mechanics is not part of JEE, but a little bit of idea you will get to know in the chapter of magnetism in class 12. The third is called statistical mechanics. And in this branch, also called the Maxwellian mechanics. So here you will study a lot about theory of probability and how the real world can be modeled into a mathematical framework using the idea of theory of probability. So mechanics which is dealt with the help of probability theory, we call it statistical mechanics. Okay. Again, you will get a glimpse of the same in a chapter called kinetic theory of gases, which is the end of the class 11 and the beginning of the class 12. The next and the last is called quantum mechanics. So quantum mechanics actually deal with something at a discrete level, how things interact. So how two charge attract or how two mass attract each other. So all these interactions can be explained on the basis of something called quantum mechanics. Quantum mechanics also uses the idea of probability theory. So there is an uncertainty also associated with the quantum mechanics, and it is mostly a discrete world. So the idea of continuity is only meant for the macro world, the world in which we live. But the idea of continuity gets disrupted the moment we enter the subatomic world. So when you go inside the atom, things are very much discrete, and everything is discrete, including the energy. So we have a very much, you can say, discreteness is a way to, you can say, describe the interaction or various phenomena. So quantum mechanics, you will get a glimpse of it in, first of all, you will get the glimpse in chemistry called atomic structure when you will study the photoelectric effect. So when you will study for the first time, it will make no sense to you. So don't worry. But when you will study again in physics at the end of towards the end of class 12 syllabus, you will get a better idea what exactly is quantum mechanics. So what is our main goal? So 95% of our syllabus is Newtonian mechanics. I would say more than that, but our primary goal is to study the Newtonian mechanics. Now we have a further classification. So we have a further classification. And then we have statistics, static, I would say, static and dynamics. And then dynamics will have again two types. Now, static you have seen already in chapter vector when we were writing the equilibrium condition, when something is at rest we call it static. But dynamics is interesting. We divide the entire course into two parts. So first is called the particle dynamics. And then we have something called rigid body dynamics. So the first four chapter is called particle dynamics. So we have laws of motion, we have friction, we have circular motion, and we have work energy power. So in the first four chapter, you only study about the particle dynamics. Then we have a buffer chapter called center of mass, which is the bridge between the particle world to the world of bodies, the real bodies. And then we have the rotational dynamics as a chapter, which you can also call a rigid body dynamics. And there we consider the dimension the way it is actually. So we take care of the length, width, height, diameter, radius, whatever. So all physical dimensions are taken into consideration when we study about the rigid body dynamics. But so far, the first four chapters that we are going to deal with, our only goal is to study about the particle dynamics, in which no matter how big the object is, even the elephant, we have to think as a point object. So if I say airplane, if I say a bus or any moving object which is of having big dimension, we treat as a point object, and we formulate law as per the assumption that everything is like a point. Okay. So later on that point we will refer as center of mass, but for the time we can assume this is simply a point. Okay. So far so good. You all have understood what I'm trying to explain here.
Yes, sir.
So from mechanics, we have come to Newtonian mechanics, and from the Newtonian mechanics, we have come to dynamics, and from dynamics, we have come to particle dynamics, and then there is something below it. So the dynamics will decide that how things will perform the motion, and it will give you some initial input. Basically, you can say through the use of dynamics, what we derive is called acceleration. So dynamics help us in finding the acceleration. But once you know the acceleration, you can basically predict a lot of other, or you can guess other information like velocity, displacement, so on, using some mathematical model. And that mathematical model we call kinematics. So kinematics is like a, I'll tell you what is kinematics. So study of motion you can divide into two parts. The first is called kinetic or kinetics, which we actually call dynamics. and then other is called kinematics. So there is a very subtle difference between the two. So when you ask your parent to for some money, let's say you want to have some chocolate or ice cream or maybe a samosa, and you're asking for some money, and they will give you, let's say, 20 rupees or maybe 50 rupees. So do you go and ask that from where you got that 50 rupees? Yes or no? No, you simply take 50 rupees and go away. What do you do? What do you do? You take the money and go away, or you inquire about the money, that how you came to you and all.
So you take it and go.
Exactly. You just take it and go away. So you are not concerned about the way it has come to them actually. So kinematics is basically a study of motion in which we care about motion but not the cause of motion. So we study motion without considering its cause. So given certain fact, you are able to predict, and that is why kinematics sometimes we also call the predictive model. But when we talk about the kinetics, it is like the income tax officer who goes to any company and they ask for the audit report, and they ask a lot of questions that from where you got this money or the transaction. So more than money, they are concerned about the way it has been achieved, or more than motion, you can say they are concerned with the cause behind the motion. What is the cause? So study of motion with considering its cause is called kinetics. So in the dynamics chapter, what we are going to learn is that what is the cause of motion, and that's very simple. You know that it is the force which creates acceleration, and it is the acceleration which creates velocity. Velocity is the motion. So we have a proper way to proceed. Okay. So now the first chapter, before we talk about the cause, we want to enjoy the life, right? So we want to have the money and we want to run away and buy something which is of our interest. So when you learn kinematics, you do the exactly same thing. You have some variable given to you. Let's say you know the initial velocity, and let's say you know the acceleration given to you. You can find the velocity as a function of time t. So we can be predicted if you know certain parameters. Okay, so given u and a, we can find v. Understood? But who is creating a, we are not concerned about. That's why it's called kinematics. Okay. So I hope the meaning of kinematics is clear to all of you.
Yes, sir.
Now, when we talk about the kinematics, then we further differentiate. So what we're going to learn in kinematics? So we study about rectilinear motion. So you make sure that the motion is in a straight line. So your first chapter, which you are actually learning kinematics, is called rectilinear motion. Then you study something called curvilinear motion. So curvilinear motion is basically motion in 2 dimensions or 3 dimensions along a path which is not a straight line. So you can say the when you throw a projectile, what you exactly study is the curvilinear motion. You can say under the category of curvilinear motion, we are going to study particularly projectile motion and but fortunately we are going to only deal with this part in this chapter, but the other one is having a separate chapter itself. So we do have a chapter called circular motion. Okay. Now again, circular motion can be part of dynamics also. So we study circular motion in kinematics also, and we study circular motion in dynamics also. In dynamics, we write the laws of motion, and in uh, kinematics, we talk about the simply motion. If something is given, how you're going to find something else. So I can put it circular motion in kinematics. So in kinematics, we also talk about something called relative motion. Then the relative motion we can further divide into one dimension. So generally we deal with 1 and 2 dimension. So what else we study? So the topic that we also comes in the kinematics is called constraint motion. But again, because of the way syllabus is defined, we end up learning this in a chapter of Newton's laws of motion, which is dynamics. So we'll be taught in a chapter called Newton's laws of motion. Although these all are part of kinematics. So in a way, kinematics is like spread out. It is not at one place. So you see kinematics also in circular motion. You see kinematics in here you can consider laws of motion. You also see kinematics in work energy power. So all these are part of kinematics. So under this rectilinear, we can study motion along straight line. there is something special called, especially the name is given, of motion under gravity. Okay. So now this is the overall, you can see the scope of this chapter. So what we are going to learn in this chapter, it's very much obvious. And we have to start. So the thing which we are going to cover is, yeah. Let me formally start the chapter. So we'll start with something called particle. In physics, the word particle is only meant for concept. The particle is not something that we can achieve. And when we say particle, we do not mean the particle in general, which you say, like sand particle or some grains. So here particle is a purely concept. So we say particle is a physical concept, and it is represented on paper as a point, which is a mathematical concept. So particle is a physical concept, and to represent it, we use a point on a paper, which is a mathematical concept. And point is something without dimension. So it's a dimensionless entity. You can say point is okay. So what exactly we study in kinematics? So before I start the topic, let me tell you some story. So I said kinematics is basically a predictive model. Now, what is the meaning of predictive model? So let's say we have to design a runway. So we know that we have to stop the plane, and theoretically we know that what is the speed of the plane which we need to lift the entire weight of the plane in the air, and therefore to stop the plane on the runway, it will take some time. So you will apply the brake, and eventually will come to rest. But before that, you travel a lot. So let's say if I'm the infrastructure builder, I mean, I'm going to develop a world-class airport. Now I have to decide for the length of the runway, for the safer landing of a plane. So before we design the runway, what we do? We try to calculate the maximum distance that the plane will take to stop itself. So for that, we need to know that what is the braking power of the plane, how much it can slow down itself. So we need some information, let's say called acceleration or retardation. So once we know this information, we apply the kinematical equation, which is well known to you, or maybe we apply something else, which is not as simple as kinematical equation. But all of these things come from the idea that how the retardation is going to be produced. So given the idea of retardation, we can calculate every other parameter like displacement, time. And because we know in advance that, okay, this much displacement it will take before it will come to rest. So for a safer side, we'll try to increase the runway length more than that. So all this decision we have taken without actually running the plane or bringing the plane there. It was only in the mathematical terms that we designed and we got the answer. And when we checked in reality, it was very much accurate. So this is called the predictive model. You have the power of prediction based on certain parameter known to you in advance. So if we have something known to us in advance, we can basically okay, understood. So the idea of a predictive model of the purpose behind saying that okay, the kinematics is a predictive model is the same. We have certain parameters known to us in advance, and given that parameter, we are able to deduce other relationship which are indirectly connected. So once you know that if you have the acceleration, you have every other information technically. So although we have studied all this thing in chapter of vector, but just as a quick recap, let me take you to the again basic definition of some of the physical quantities that we have described earlier. So I'll just do it again. So what is quotient vector, guys? Every point in space will have meaningless presence until we do not have the origin or some observer. So a point gets its due location only with respect to some origin, isn't it? So when you have a point P, then so position vector is simply it is a vector representing a point in space with respect to some origin. Correct? That's the definition. I hope you remember this definition. It is the position vector of a point in space Just so it is the position vector of a point in space with respect to some origin, or you can say observer. So we have done this all these things in past. So given the coordinate of the point P, let's say x, y, z. What, how we write r vector? Tell me guys. R vector equals to, how we represent r vector? Am I audible?
Yes, sir.
So given the coordinate system, what is r vector?
Sir, xi cap plus yj cap plus z k cap.
Very good. So it is simple. You just write the I, J, and K. You get the vector. Okay, so this will also test your memory about the vector, how much you remember the vector. So I will not waste time because we have discussed all this. And if you have forgotten everything, then let me know. So if you have, if you remember something, then let me know. I'll just go quickly. If you don't know, then also let me know. I'll try to explain again. So the second definition is called displacement. What is displacement? So displacement is a vector quantity, right?
Yes, sir.
So what is the definition? So what is displacement? Definition.
So can we say the minimum distance between 2 points?
No, displacement is a vector. So how can I say in terms of distance? It's a scalar. A vector must be defined in terms of vector, no? Come on, guys. The definition.
Velocity into time.
Yeah, that's good. Wrong about it. But what is the displacement? The definition. The answer is in front of you only. This is the answer. Change in position vector is called displacement, isn't it?
Yes.
That's it. So it is change, no? We've done this. So anyway, try to recall things. So if you are here at some moment and your coordinate is x1 comma y1, you take some random path and you come to a new point. So for the observer at O, your initial position vector is this one, but your final position vector with the same observer is here. So if I call this is R initial or R1, so you were at one and then you got displaced to the new position, and this arrow, this vector, is the displacement. So from triangle, what you can say? It is clear. So it is R2 minus R1. And how to write the R2, guys? Tell me, what is R2 here? What is R2 vector? Siddhant, tell me.
Y cap
X2 I cap plus Y2 J cap.
Very good. So what is R1 here?
X1 I cap plus Y1 J cap.
Very good. So you know the displacement is how much? X2 minus X1. I cap. So in general, you can extend for 3 also. So in general, it is X2 minus X1. That's very simple, like nothing. So we just move quickly. This is just a recap. I know you all know everything. So quickly, guys, the third point, what is velocity? Definition first. What is the definition of velocity? The rate of,
change of displacement with respect to time.
very good. So the rate of change of
position vector.
yeah, both are true. So whether you said displacement or position vector, both are correct. So once you define something like this, the problem is, can we express this as a mathematical value or mathematical relationship? So how to write mathematically? Tell me, guys. The answer is we cannot write. Why? Mathematical definitions are very much specific. So every time you have a definition, it will have two mathematical forms and maybe more than two also. So the first is called average velocity, which we represent by the symbol like this. Or you can choose to write V with A, V, G. And once you call it a mathematical definition, once you call average, then it will have some form of writing. So until we are not using the mathematical definition, we have no way to express it. So it's a very simple definition. So when we try to define the average value of anything, we say total displacement So total displacement upon total time. Understood? And now you can write a mathematical definition like this. Delta R by, that's simple. Or you can say final minus initial. And the B part is called the instantaneous. So the word instantaneous is also equivalent of average. The only difference between the two is that the limit, the time interval in which you calculate the average is tending to 0. And from the calculus, we know that the delta t tends to 0. The delta r will be also very small, and this will be represented. So the instantaneous velocity we write like this, not the velocity in the technology. So we don't have the formula for velocity. We only have the formula for instantaneous. Okay. And every time we have the instantaneous and average, we can relate the two. Why? So this is also from the differential equation dr equals to. So some time back, person told me that displacement is velocity in time. So again, it depends on which velocity. To find the total velocity, total displacement, what do we have to do? Integrate. And therefore, the relation between average and instantaneous. So average we define as, which you can rewrite as. And remember, you cannot take v out of the integration because see, we have no idea whether v is constant or variable. So if v is constant, you're lucky, you can take it out. So in that case, the average will be same as velocity. Okay. Is this clear so far?
Yes, sir.
So a quick question. If the position vector of a particle is given by okay, solve this question. I'm coming in 5 minutes. Just solve this quickly. Okay, so got the answer, guys? So what is the average for the interval T0 to T3? Answer for the first part. So what you're supposed to find is what is R at T equals to 0. So what is R at T
Sir,
equals
is
to
it
0?
7?
7. Okay, I'll just check it out. So what is the R value at T equals to 0? Tell me. So you have to put the value 0 in the formula to get R T0, right?
Yes, sir.
If you do so, what you get is 5 K cap, right? And what is R at T equals to 3?
26.
See, we have I, J, and K, na? So how it is just 26? Have you added all? When you put 3, it's 9 to 18 I cap, 3 J cap, and 5 K cap. And what you have done is you have added all values. It's a vector quantity. Can you add like this? No,
No, sir.
that must be wrong, no? So what is delta R? R final minus R initial. Just follow the steps, you will get the answer. Okay. So the answer is 8I plus 3J. 5K will cancel out. So what is the average velocity definition? Always remember the definition. Don't try to use formula. The moment you apply the definition, what is the definition? Total displacement upon time taken, which is 3. So the answer is 6I cap plus. And if I ask you what is the modulus of average? The modulus means you take the mod once you find the value, just take a model, what you get? Okay, so this is the answer. Now for B part, finding V at a given time means what they're asking is called instantaneous velocity. So what is the definition of instantaneous velocity? So dr by dt, and that will be how much?
4t plus 1.
40 I cap plus j cap. And now we are looking for t equals to 2. So now you can substitute t2. Don't substitute in the beginning. First you get the velocity, then substitute. And when you put 2, what will get the answer?
8I plus J.
So the mod of instantaneous will be how much? Yes, so this is in. I hope this is clear, guys.
Yes, sir.
Yes, sir.
But what you did, Siddhant, was something miraculous. Huh? How you added I, J, and K together. So you have added the apple with orange with banana, huh? All 3 together. You are saying 26. Okay. See, the biggest problem with kinematics is that you have to follow definition. If you miss the definition, you will miss the answer. Okay. Sorry. So let me just recap those questions which we have done already. Okay, guys. So your circular path. So a particle is moving in this path. Okay. So the idea is you start from somewhere, maybe here, and after some time till you are here. So the arc which you have traversed, that arc will subtend an angle theta like this. So the answer must be expressed in terms of theta. So what is the average velocity from here till here? That's the question. So question is clear to you guys? You have done this before also. Can you derive it? So solve this question. Meanwhile, I'll write the next question. So this is your next question. So solve this, guys. I'm giving you maybe 5-6 minutes to solve. Once you're done, let me know. Hello guys, are you there?
Yes, sir.
Yes.
Done? All questions are done? So what is the answer for the first part? Tell me.
R theta by T.
R theta by T, but T is not given actually. And what we are asking is this is what is given to you is the V. So you're saying V is R theta by T, right?
Yes.
The speed is distance upon time. So the time is how much? Because we want to express the answer in terms of theta, right?
Yes.
So we got the time interval, let's call it delta, which is same as T. And now, what is the displacement? What is the delta R? So you have gone from here to here, right? And in this triangle, we know how to find this length. So this is your isosceles triangle, right? So in this isosceles triangle, if you just think about the displacement, this is your displacement. You realize this. Your displacement is the beginning and the end point, isn't it?
Yes.
So how much is that? And we have done this in vector. So I expect that you guys should be knowing this. What is the answer? Come on, tell me. Okay. So just think, look, don't worry, this is simple. Think as a triangle. Can you find the third side of a triangle given the two sides and theta? So given theta and r, can you find the third side? Is it a bit difficult? So you can use cosine formula, you can use isosceles idea. We have done all this thing, but still I'm giving you this question again. This is the second attempt. So I expect that you should be good with calculation. So what is delta R? Tell me. Anyone?
Sir, is it 2R sine theta?
Is it 2r sine theta? It's very close, very close. Something more. It is 2r sine theta by 2. Because you need
Yes,
to
sir.
draw,
Sorry, theta by 2.
you need to draw a perpendicular, right? So once you draw a perpendicular, you will see that this is half angle. And then we know this is r sine theta by 2. So the whole length is. So this is 2r sine. So what is the definition of average velocity delta r by delta t? Now to find the modulus, we take mod both sides. And because time in itself is positive, so delta r by delta t. So because we know all answer. So in the beginning, this kind of questions are difficult for most of you, but it's very easy. If you just think about definition. So your answers to are and R gets cancelled. So the answer is 2v by 2v into sine theta by 2 by theta, which you can rewrite in a nice way as okay. Tell me guys, is this clear? Yes or no?
Yes,
Yes.
sir.
And what about the next part? So T is the time period. So let me solve one of them. So if you take the first part, in 1/4 time you will travel 1/4, isn't it? So if we start from here, in 1/4 you will be here, right? And therefore, what is the distance, guys? So what is the displacement? This is pretty easy to find, no? If R is the radius, what is the displacement?
2r.
Hmm? How much you said? Delta R is
Root 2r. No?
2R. Very good. And what is the time interval?
T by 4.
No. Oh yeah, that's fine. So now the average will be how much? What is the modulus of average? Root 2R by. So similarly, if you do it for the B part, so T by 4, this is T by 2, this is 3T by 4, this is T. So 3T by 4 means you are again here, right? So displacement is again same, root 2R. Now the time is more. For C part, who will tell? So then now that's a tricky part. T by 6 means you need to find the angle first. So T by 6 is before T by 4, right? Let me see if you can solve it. Do it.
6R by T.
6R by T. But how you got 6R? So how much you got displacement here?
I got it as 2R sine 30.
Oh, very good. 2R sine theta. So theta by 2 is also fine. So this will become and we know theta we can write as omega into t. Or you can simply say theta equals to. So in one time period you travel 2 pi, so 2 pi by 6. Correct?
Yes, sir.
So the angle is pi by 3. So the answer is 2R sine pi by 6 by t by 6. Pi by 6 is how much? So I think Raghuveer has got the right answer. 6R by t. This is what you got, right, Raghuveer?
Yes.
Excellent. Very good. So you need to find the angle proportional to the time period and get the answer. So what about the D part? So it is 4/5 of the 2 pi.
So can you please explain the C part again?
Okay, for any displacement, for any angle theta, what is the answer? We know the answer. Check here. Displacement for any angle theta is how much? 2R sin theta by 2, yes or no?
Yes.
But the angle here is not given. No? So how to find the angle? So we have time period given. So in t time period, how much angle you travel? 2 pi. So in t by 6, how much you will travel? What angle you will traverse?
2 pi by 6.
Which is pi by 3. Correct?
Yeah.
And what is the formula of displacement? 2R sin theta by 2, which is pi by 6. No? 2R sin pi by 6. Pi by 3 by 2 is pi by 6. No? Yes or no?
Yeah.
And we know sin pi by 6 is sin 30 is half. So this will cancel out. So 2 and sin 30 will cancel. So what we get is R by T by 6. That means 6 R by T. Okay.
Yes.
Is this clear? So tell me the D
Yes,
part.
sir.
Tell me the D part. Everyone.
Pi R sine 144 degree by 2T.
Okay.
Yes, sir. Same.
Very good. So D part is how much you said?
Pi R
5
is
hours.
phi.
Pi R.
Digit phi. No pi.
Okay. Okay. 5 R. Okay. 5 R. Yeah.
Sine 144 degree by 2T.
All right. That's okay. So the theta here is how much? 4 by 5, 2 pi. 8 pi by 5. So theta by 2 is how much? So 4 pi by 5. So displacement is how much? So the average is you can either leave as 4 pi by 5 is okay. If you put pi equals to 180, how much you will get? 36 into what you're saying is correct. And time was how much? 40 by 5. So your answer is absolutely correct. Now next, we go to the next concept. So after displacement and velocity, we can do something called acceleration. So what is acceleration, guys?
Rate of change of velocity with respect to time.
Time rate of change of velocity, right? Since
Yes.
velocity is a vector quantity, so in how many ways we can change the velocity? Okay, tell me, in how many ways we can change the vector? When we say a vector has changed, tell me.
Magnitude is changed.
Correct. What
Or
else?
direction.
Or direction or both. That's it. So we have three ways. Na? Either you only change the magnitude, or you only change the direction, or you change both. In all three cases, you can always talk about the what? Acceleration or velocity has changed. So when you want to change the velocity, it is not necessary that you must change the magnitude. You can also change the direction. Still, the velocity is said to be changed, and then we will have acceleration. So acceleration is the time rate of change of velocity, but velocity is a vector quantity, so you can change in three possible ways. So let's say if you have some random path, and this is basically example of curvy linear motion. At some point, your velocity is directed like this. And at some other instant, the velocity is like this. So if I call this as v1 vector, this we have to call as v2 vector. Now we can say that velocity has changed for sure here, isn't it? So even though if you maintain the magnitude, your direction is continuously changing, so we can say the velocity has changed. Okay. So the word acceleration, again we'll have two definitions. Average, and the average acceleration we have to define in a similar fashion. The change in velocity vector. So you can say v final. So instantaneous is always the limiting case of average when the time interval is tending to zero, isn't it? Tell me guys, do you remember this definition? Yes or no?
Yes.
So the acceleration is very simply defined. Just if you want to find the instantaneous, differentiate one more time. But to find the average, Just find the change. And we have done a very interesting question, the bird question. So quickly we can solve this question. A bird is flying with a speed of 10 meters per second towards east. Then it takes a sharp left turn and continues to fly with same speed. If the time taken to negotiate the turn is 10 seconds, then find the average acceleration of bird only in magnitude. So we have done this before, but you can try once again. The second question that you have to solve, you are supposed to solve is the same question we have done. Find A as a function of time. So nothing like, not at any specific instant, just find it. Solve this question.
Done, sir.
Okay, sorry guys. Tell me if you have got the answer for both.
Yes, sir.
So for the first part, what is the answer?
So
Root
root 2
2.
meter per second square.
I think this was the right answer. Yeah, very good. And for the B part,
2.
2 meter per second.
yeah, 2I cap, right? That's correct. Meter per second. I can call if the unit is known. Okay, so this is what you already knew, right? Now, the acceleration is not only of two types. I mean, we'll define something called types of acceleration. So the acceleration which is due to change of magnitude is we call tangential acceleration. And the other is called centripetal acceleration. And this acceleration is due to change of direction only. And the word acceleration that we have been using is called total acceleration. So the acceleration that we used to solve the question, that A was actually representing total acceleration. So by default, when I say acceleration, I always say the total acceleration. It is clear? So when I say acceleration, I always say the total acceleration. It is clear? So the tangential we represent by symbol AT, and it is defined as rate of change of the magnitude of velocity. Remember here we are differentiating the modulus, and there is a very fine difference. The meaning is very fine. So if someone is writing so this acceleration, what A is representing here? Can you guess? Is A representing tangential or total or centripetal? What if you? So what A is representing here?
Centripetal.
No, it is representing total. So you are finding the mod, you are differentiating the velocity. You are getting total. This is the magnitude of total. So what you're doing inside the bracket, inside the modulus sign, inside the modulus, you are differentiating the velocity vector. So when you differentiate the velocity vector, what you get? Total acceleration.
Yes, sir.
But if you look carefully here, what we are differentiating here? We are only differentiating the modulus value of velocity, the magnitude of velocity. So when you differentiate the modulus, you get tangential. But when you differentiate the velocity, what you get is always total. Understood?
Yes, sir.
So centripetal will have a different. So centripetal acceleration is also called sometimes normal acceleration. So the normal means like normally perpendicular. The normal here means perpendicular. If you are moving in any random path and at any instant, if your velocity is something like this, centripetal cannot change the magnitude. And because centripetal cannot change the magnitude, it must be at right angle to the velocity. Common sense. Why? Because any acceleration which is at right angle to the velocity will not affect the magnitude, right? So centripetal is always at right angle to the velocity vector. And tangential can be along the velocity or against. So I'll just take it along. And the total will be like this. So this is called total acceleration, which you call A. Okay. So the tangential and the centripetal are mutually perpendicular, and A is the resultant vector. So the way we can write A or mod of A. So mod of A is under root of. So if you look at the triangle, this is AC. So the mod of A will be how much, guys? You can use the Pythagoras. You can write the total acceleration, you can write as AT square plus AC square. What is AT, by the way? So we know AT is basically D mod of velocity dt square, and AC square I'm not putting the value because I haven't taught you what is AC. But from the high school you might be knowing AC is basically V square by R, where R is called the radius of curvature, but that's something which we can ignore as of now. Okay. So the acceleration will have two types, but as of now you just need to know that there are three types of or three ways to define the acceleration. One to change the magnitude, other to change the direction, and the last is to change both. So the when you change both, we call the total acceleration. And when you differentiate velocity vector, what you get is total. And when you differentiate magnitude, what you get is tangential. So the good thing is if you know A and AT, you can easily find the AC. Even if you don't know AC, that's totally okay. So A will be A square minus AT square. So technically, we always find A and AT, and we can get the AC as a relation between these three values. Okay. Let me show you the elementary way of getting this answer. Imagine this is the velocity vector at any instant t. and after time t, plus dt, let's say. So after time, this is at t. But at very next moment called t plus dt, you have new velocity called v plus d. So if you use a triangle law, because the v plus dv is this way and v is this way, just so this is if you know that this is v vector, if you know this is v plus dv. So what is the red line representing, guys? Tell me. The red line is representing what? Any idea?
Resultant.
No, so that is representing the change. This is dv actually. Now you can apply the triangle. No? This plus this equals to this, isn't it? This vector plus this vector is equal to this vector. Triangle. No?
Yes.
A plus b equals to, so what I have written is that only. No? V plus dv is this vector, which is v plus dv. So if I say this is the vector v, and after some time you change the direction and you change the length also. So let's say after time dt, what is happening? You can clearly see the vector has turned and expanded. So the magnitude has changed, isn't it? And because the time is very small, how much will turn? Very small, elementary value. So so now what you need to understand is that the dv is actually representing the direction of the resultant axis. So the red line itself is the direction of total acceleration. Do you realize this? Because total we define as dv by dt. So direction wise, A will have same direction as the dv, yes or no? So A will have same direction as dv, yes or no? Tell me. Hello, hello, hello. Are you guys able to understand that A will have direction same as dv?
Yes.
Because they are equal, no? Because dt will have no direction. Dt is like a scalar. So direction wise, A vector will have same direction as the dv vector, and the red line is actually representing the total acceleration. Okay. Now, if you remember the elementary that we always discuss in mathematical tools, using the small vector, which is the v vector, if you draw a perpendicular, so can you find this length? What is this length? Think as the arc of a circle. So this length is how much? So the length of the small vector we can call as v. The angle turn is d theta. So if you draw an arc like this. And if I take the radius as V, what is this length, guys?
V d theta.
Very good, excellent. So V theta is actually representing change of direction. So this contribution, this is V d theta, is the change of direction part, and this length is the change of length part. So this is the dV modulus. Sorry, d of modulus of. So the length has changed by that value, and the V theta is the change of velocity due to direction. This is called so this will be changed due to change of so how many of you are able to realize that this is the change of direction, this is a change of magnitude? Are you guys able to realize this?
Yes, sir.
Okay. So to find the centripetal, what do we do? We take that change which is affecting the direction. So we call V d theta by d. And for the tangential, we take that component which is affecting the modulus, dV modulus, and A we write as. So when you differentiate this part with time, what you get is A. So do you realize these three relationships, everyone? And you have to be very careful that when to use, how to use. That these terminologies are very similar in looking, but they are not similar. So d of V by dt is different than d of mod of V by dt. So the meaning will change entirely. The way we write will affect a lot. We have to be careful about the way it is written. And later on, we will come to know in the chapter of circular motion that d theta by dt is called angular velocity, right? So we have done in the dy by dx as rate measure a lot. So we have seen d theta by dt, right? Is this clear?
Yes.
So now don't worry, we are going to discuss this again in circular motion, but you should know right now why. Because in Eroda, we will get a lot of questions which are based on this, and just knowing this definition is good enough to solve. So for circular part, So if the path is circular, then in time dt you will travel v dt. Let's say v is the magnitude. So v is the magnitude at any instant. So we call that you will travel v dt in the time dt. So the arc length will be how much? V dt. So we can write angle subtended equals to v dt by r, and therefore d theta by dt becomes v by r, and that is why the AC formula is v omega. But you can now write as what? Or or you can write as, so AC will have three definitions. Okay. Okay. So the analysis of acceleration is clear to all of you.
Yes, sir.
Can you guys derive on your own? Without looking at it? You can see and derive. Like look at this. Try to rewrite all this thing on your paper so you can keep on seeing. Go back and forth. Try to derive on your own. See how difficult it is. Try to realize this. Are you able to derive this again on your own?
Yes, sir.
And if you are deriving it, try to realize every bit of it. Every term which I'm writing here will have some meaning to convey. Make sure that all of you are able to get that meaning first. If it takes more time, give it, that's okay. We are learning the most challenging part of kinematics, the acceleration. Done, guys? Is this part clear to all of you?
Yes, sir.
So before, okay, how many of you, I mean, honestly practiced all this derivation? Raise your hand.
Sir, I
Yeah, I Prasansa, Rugved, Shreya. So what happened to you, Prasansa and Rugved? Why you're not doing this? Are you not getting it?
I'm getting it. I don't practice derivations as solve problems.
These are actually the building blocks of solving problem. So once you are able to do this, you can do any problem, be it whatever difficult. Prasansa, what about you? Why you're not able to derive this?
So I derived this. I was talking about solving problems. I don't practice it.
That's a basic mistake I mean, which you should not commit. That always work more on derivation. The problem will solve automatically, and you will also realize this what I'm saying. Okay. So let's do before I wrap up today's lecture, the last question. You have your lecture, I mean, guys, after this.
yes, sir.
Okay, so what I'll do is I'll start with in the next lecture, but I can give some homework which you're gonna attempt. Like so these are your homework for today. So the next lecture will be discussion about all these problems. So you have to practice this, and we'll discuss every question which I have given. Now, to solve all these questions, you need to understand the derivation part much more than what you have done so far. So formula will not help much. You have to do this aggressively using derivation. So we'll see this question. You can make a first attempt. I mean, before the next lecture. Don't worry if you get 2 or 3 questions. That's even okay. But make sure that you attempt. The next lecture will be all about how to solve problems. Okay. Bye guys and take care.
Bye, sir. Thank you, sir.